Hello everyone. Welcome to the first module, which is Origin of Blockchain. In this module, we will discuss various events that led to the development of the Bitcoin and blockchain technology. For this particular session, we will first understand why there is a need for the trust between electronic systems, how it is achieved, and after that, we will compare the different architectural styles of a network in a system. Let's start with electronic systems and trust. Before blockchain, the idea of cryptocurrency and the systems reliable to operate that currency was just a dream. The internet was required to be distributed, reliable, and it needed to be used by almost all of the population as it digitally connects the world together. The internet at the infant stage was just a simple and small network, which was only used by the university researchers and the US government authorities to share information digitally. As the time passed, the internet pioneers made the system more usable and reliable. The development of TCP/IP networking architecture made a huge impact on the usage of the internet. It established the standard for communication such as HTTP, which is used to provide web browsing, and SMTP, which is an electronic mail delivery service. These protocols made the internet usable not just for the researchers, but also for common people in daily usage. It brought up a small revolution in the digital world, which resulted in the growth of devices connected to the internet, including tablets, smartphones, and many more. Even though the internet has changed the life of a common man forever, using most of the online services requires a third party to vouch for the security and trustworthiness of the service. The systems always required two different types of trust. First is intermediary trust, which means a person who is relied on to make relational and fair decisions. And the second is insurance trust, which means a third party who is responsible for making decisions that is related to the safety and soundness of a value. Financial transactions using the internet is one of the major problems, where trust is not just necessary but also mandatory, as it deals directly with cash. For multiple and situation-dependent reasons, paper-printed cash issued by the government is not the first choice of people to spend their money. Nowadays, people are preferring electronic methods such as credit or debit card payments than before. In some countries like Sweden, almost all of the payments are shifted to electronic methods, with most customers habiting their life to smartphone payment methods. Although cash is readily available for use, preferred payment methods are changed to digital payments. When value takes a digital form, that is when it is moved from physical items like coins, notes, metals like gold, silver, platinum, etc., to digital, there is a need for the trust among the people involved in the transactions. There are multiple windows available for one to make a fraud and cheat on others. For this to be avoided, huge payment companies like Visa, Maestro, etc., round the globe are established with the idea that people storing their values digitally are able to trust and rely on them. Well, trust is never stable in the financial world. The 2008 financial crisis made people have second thoughts on these organizations and banking systems, which play the main role in digitizing the cash. People began to think that they may have trusted them blindly as there was no other option available, and they later realized that these organizations are not much reliable further. This is one of the main reasons in the pile of events that led to the creation of the mighty digital currency Bitcoin. The blockchain technology is an effort that was made to re-establish the long-lost trust in digital transactions. It is made up of technology to build trust, specifically cryptography, which is used to deal with critical data, to automate and enforce the trust into the system. Bitcoin was the first working cryptocurrency system that was built using the blockchain technology. There were many players who tried to establish digital currency and failed. One of the many reasons for their failure was that they were unable to put a fully distributed system on the internet for the system to work. Now let's learn about distributed, centralized, and decentralized architectures. Any piece of software that is connected to another system must follow a systematically designed architecture for connection management, scalability, and efficient use. There are three different types of architectures available that are used according to the business needs, user flow, and nature of the network that the system is using. The widely used and most popular network architectures are centralized architecture, decentralized architecture, and distributed architecture. Let's understand centralized architecture. In the centralized architecture, there are two types of nodes that participate in the system. The first one is the server or supernode, and the second one is the client or user node. The supernode is the heart of the network, which stores the data and provides services to the clients connected to it. It is the traditional and simple method of maintaining a network, where there are multiple users requesting for a service or data, that includes user information or user-generated content, and much more. This approach is mainly suitable for organizations that are located at a single location, as it is a standalone network, in which the users are not spread over a wide geographical area. The main advantages of this type of system are that only the server needs to be heavily equipped with advanced hardware and software, because it is the only node that undergoes a huge workload, and the clients need not to be operating with advanced hardware. The client nodes may need to use some special type of software, depending on the services provided by the network. There are tons of centralized networks available around us. For example, a school network, a home Wi-Fi network, etc. It does not require much effort to establish the network, and it is easier to manage the system. The traditional approach comes with its set of advantages and disadvantages. The advantages of this approach are as follows. Number 1. It is simple for deployment. Number 2. The development time for this approach is relatively short. Number 3. It is cheaper, which means the development, deployment and maintenance costs are less. Last but not the least, it is practical when there is a need to control the data at one location. Now let's see some disadvantages of this approach. There is always a chance that the system is prone to failure. There are higher security and privacy risks for users. It requires longer time for accessing the data for users who are physically far from the server. Now let's explore decentralized systems. As the name suggests, the system is not centric, it is distributed to multiple supernodes or servers. Every supernode in the network is connected with at least one another supernode. Each supernode contains the same copy of data available and must provide the same services as other nodes. It is a debatable point that the decentralized system is an advanced centralized system with just multiple servers, which are connected to one another. There will be no supreme node to the supernodes, and all belong to the same level of dominance. The decentralized system is also vulnerable to crashes, just like the centralized systems, but it is designed to be fault tolerant. The system is designed in such a way that, whenever a server has failed or is set offline for any reason, one of the adjacent servers can take over the responsibilities of the failed server until it is set back online. In this way, the users never have to worry about the availability of the services and can always have access. The system remains active until one of the central servers is able to operate. This means that the system owners can fix the faulty servers, while the system itself is providing the services to the users. The server may not be able to affect the availability of the services, but it definitely affects the system's performance and limit. The pressure on the adjacent server that took over the faulty server will be increased, which results in the increased response time, which degrades the user experience. This architecture is well suited for organizations that have a huge user base and are spread over a wide geographical area. By having servers at multiple locations, the lag in accessing the system is a more unlikely scenario. The best and well-suited example for the decentralized system is the Bitcoin network. It is spread over the globe with huge server bases over multiple locations around the world, which serves millions of users and is available 24/7. The advantages of using decentralized system are as follows. The system is less likely to be unavailable for users than a centralized system. It assures better performance in availability and response time. It provides space for diverse and flexible systems. Now let's see some disadvantages of using decentralized system. There are some security and privacy concerns to be taken care of, as the data is available at multiple locations. The maintenance costs are higher, because we are maintaining multiple servers, which are high-performing computers with advanced hardware. The system needs to be properly optimized, else it leads to inconsistent performance. Next, we have distributed systems. The distributed systems are similar to the decentralized systems with one exception, that is, there are no supernodes in the system. A distributed system is the same as a decentralized system with no central owners. In distributed systems, users have the same level of data access, though user privileges can be restricted if needed. The distributed system allows sharing ownership of data, and the software and hardware resources can also be shared between the users in some cases, which will boost up the system's performance. A distributed system is safe from the failure of the individual components. Even though some nodes failed, the whole system won't be affected, thus increasing the uptime of the network. The distributed systems are designed to exceed the limitations of the regular systems. The increase in security, data storage and the privacy concerns and the feature of instant scaling, distributed systems made its position as a primary choice for many organizations for their network issues. The pros of distributed systems are as follows. The system is highly fault tolerant. The network will be transparent and more secure. It promotes resource sharing that can reduce burden on single or selected machines. The network can be extremely scalable. Now let's see some cons of using distributed systems. It is more difficult to deploy a network. The maintenance costs are higher than any other method. That's all for this session. For any query, please visit community.blockchain-council.org, and you can also email us at hello@blockchain-council.org. Thank you.